Hey guys, welcome back to Porter Podcast. We just got done tying Mount Juliet 2-2 last night after Mount Juliet? Alright, stop making fun of the way I talk. Alright, here we go. Last two problems we're going to cover before your test. One deals with solution stoichiometry, one deals with gas stoichiometry. Remember, you have to have a gas at STP in order to do any gas stoichiometry. If you are not at STP or you do not have a gas, you cannot use the molar volume. Remember, standard temperature and pressure is equal to 0 degrees Celsius and 1 atmosphere, 1 atm. Under those conditions, 1 mole of a gas is equal to 22.4 liters. So we can go from volume to 2 moles, and then from there, mole ratio. All right, so we're starting with 50 milliliters of oxygen gas here. Where are we going to?
Molecules of water.
Molecules. So at some point we need to use Avogadro's number to go to molecules. But first we need to get to water, particularly moles of water. So we're at milliliters of O2. I know at STP, 1 mole is equal to 22.4 liters, so we need to get our milliliters to liters. So 1,000 milliliters equals 1 liter. And I know 22.4 liters at STP equals 1 mole of O2 gas. Now, your mole ratio between O2 and H2O, 1 mole of O2 for every 2 moles of H2O. And I know 1 mole of H2O is equal to how many molecules? 6.022 times 10 to the 23rd molecules of H2O. 50 divided by 1,000 divided by 22.4 times 2 times 6.022, second EE23, enter, will give you your answer. 2.69 times 10 to the 21st molecules of H2O is your answer. Remember, H2O is a covalent compound. We use the term molecules to describe covalent compounds. What do we use to describe ionic compounds? Formula units. Formula units. So, when we're talking about solution stoichiometry, we generally are talking about stuff that has dissolved into water. Particularly, we look at formula units in most situations, for this class at least. So, what are we starting with here? We're starting with 60 milliliters of sulfuric acid. 60 mils of H2SO4. Now, how do we convert from a unit of volume to a unit of moles? Remember, your concentration units are how we convert from volume to moles with a solution. So that big M stands for what? Molarity, and molarity is equal to moles over liters. So those two units allow you to convert from a unit of volume to a unit of moles, or unit of moles to a unit of volume. In this case, we have a neutralization reaction. We are neutralizing sulfuric acid with potassium hydroxide. Based on the concentration of those two solutions, you will need a certain amount of potassium hydroxide to neutralize your 60 milliliters of H2SO4. So we need to convert from H2SO4 to potassium hydroxide to determine the amount of base that you need to neutralize your acid. We're at milliliters, we need to get to liters. 1,000 milliliters equals 1 liter. What's your concentration of sulfuric acid? .5 molar, which equals 1.5 moles over 1 liter of H2SO4. So my 1 liter on bottom, my 1.5 moles of H2SO4 on top. That's how you plug in your concentration unit to convert from liters to moles. Now, mole ratio between H2SO4 and KOH. 1 mole of H2SO4 to 2 moles of KOH. Now notice your KOH has a different concentration than H2SO4. So we plug in 3 moles per liter for KOH. So there are 3 moles of KOH for every 1 liter of KOH. Last step, it's asking for the volume in milliliters. So 1 liter, we convert it back to milliliters. 60 divided by 1,000 times 1.5 times 2 divided by 3 times 1,000 gives you your answer. If you want to simplify it, 1,000 cancels out with 1,000. 1.5 times 2 is 3. 3 divided by 3 is 1. So those cancel out. So do we have to even calculate this? No. Your answer is 60 milliliters of KOH.